Hi, everyone. Dr. Sheftall here with Dr. Bhattacharya. Tonight, Dr. Bhattacharya and I are going to wrap up the long series that we did last spring. Um, Hi, Jay. How are you?
Nice to see you, Reed.
Great to see you. You've been very busy, and that's why we haven't been able to do this last segment. Been traveling
Yeah,
a
I've
lot.
been traveling all over the place.
Yeah, that's great. I want to hear all about that in just a second. So, for the audience out there, this will be the final one, and it's going to be a fun night, and we're going to wrap up lots of things and maybe introduce an idea or two at the very end, but it won't be too long. I think we'll be under an hour tonight, Jay, but we've said that about 10 times already. Okay, so you ready to start?
Absolutely.
Great. Uh-huh. As always, got to go to this thing to get the first one to work. Did your screen change, Jay?
Yes.
Great.
Oh gosh, how on earth did you find these?
Yeah, well, I had to look around for them, but I'm going to show you my page in a second, and there's a few pictures of me from 15 years ago, so I thought I would put a few in of you when you were young. And I'm really intrigued by that middle one. It looks like you're in black tie. What's that about?
It was my brother's wedding.
Oh, wow, really? Okay. Uh,
Yeah. How many years ago was that? It's like more than 20 years ago.
yeah, these remind me of the picture you had with your children when they were really small in a previous episode.
Yeah.
Yeah,
Those were good times.
yeah, they were, I bet. Okay, so anyway, you've got a tremendous resume, Jay. Um, all these degrees from Stanford. And I wanted to ask you about one in particular, and that was the Institute for Economic Policy and Research. Is that a thing like the Hoover Institution that's just connected with Stanford, or is that part of the
Yeah.
university? Okay.
Yeah. Well, I mean, Hoover is part of Stanford. So is
Yeah.
the Stanford Institute for Economic Policy Research. It was started actually by my I did an honors thesis with this man who started the institute, who's a Stanford professor, and he I mean it basically collects people all around Stanford who are interested in policy, interested in applying social science research methods to policy questions. John Chauvin was his name.
Wow. Very good. Well, you wear a lot of hats over there. That's very impressive.
I mean, you got to keep busy, Reed.
Absolutely. Now, are you 6 feet two or what?
I'm 6 feet, not
Oh,
two.
you're only
Not two.
6 feet?
Well, I'm 6 feet and a half inch.
Wow. Because when we met in person, I was kind of shocked at how tall you were. Maybe I'm shrinking. Let's see. Okay. So here's
uh,
my,
that half inch is key
pardon me.
because my brother's only is exactly 6 feet. So
Oh, gotcha. Okay. I know where that's coming from. I got a brother too. Okay. So here's mine. And these are pictures from the last, I guess I was 56 in this one. That's 10 years ago. This one, I think I'm 48, and this one I'm 50. And this is just a patient from Operation Kids. It's listed here somewhere, right here, which is the burn reconstruction thing that I do. And I do heart stuff now. But anyway, these are my two things that I do over here in Cambodia
Reed,
and
you're
Vietnam.
you're you're just a good man.
Uh,
I'm devote your life to this is an amazing thing.
Anybody would do it if they
An
had
honor
the
to talk with you.
no big deal. Now, I thought you'd get a kick out of this down here. This is the book. Um, and as you can see, Dr. Burks has one ahead of me there. Number five and number six. I think that's in infectious diseases or something.
Oh my goodness, Dr. Burks.
Yeah, isn't that amazing?
I,
I
I,
don't,
I imagine she shows up in your book as a hero or as a villain.
she's the villain, and she's ranked number one on the worst villain list too for women. We'll get to that in a second. But anyway, there's my page there. So let's talk about the contents of tonight. And it's going to be pretty quick. There's four things we're going to cover, and a couple of them are going to be really fast. But I came up with another way to explain why lockdowns are precisely the wrong thing to do, which I think you'll like. Remember the slide that I called it a cheesy slide with the community and everyone's out and about. And then when they started the lockdowns, everyone's in their house everywhere instead of out in the athletic fields and everything. This one's a little bit different. This is a little bit more rigorous, but I'll show it to you. And then asymptomatic transmission which you'll remember you had the data proving that it existed. And I kept saying, no, it can't exist. It's a first principles violation. It turns out we were both right. And you'll find that very interesting.
Okay.
And then you asked me about how could I have figured out so quickly that the vaccines were not blocking transmission. So that's a topic. And I show you what I needed to know and how I knew it. And also I found a screenshot of that earlier video that I kept telling you I figured it out on January 15th, which seemed really fast. But I have a screenshot from that and it shows it. So I'll get to that. And then at the end, of course, the big question of all, which you probably might disagree with me on, and was there really a pandemic there? So let's get on to this thing. So here's the slide about the lockdowns. And here's the problem with people going into houses and staying in there. What we've been stressing the whole time is that you really want to make the indoors of a house as much like the outdoors as you possibly can. And the reason is because these virus particles will accumulate in the house when the air is stagnant. Just like if you're running a marathon on a 440-yard track, a 400-meter track, and 100 meters of it is 4-inch thick sand. After you've run about 20 or 30 laps, there's going to be way more people in the sand than there are on the hard part of the track all the time. Do you agree with that?
Yeah.
That's kind of what happens to these virus particles when they're in stagnant air. So houses are the worst thing you could have asked people to go into. And it was equally stupid to have those plexiglass walls around all the desks in a business office too. What they needed was a little fan to just keep the air moving. You see what I mean about the stagnant air?
That's I completely agree with you, Reed, about this. We knew very early on it was aerosolized. We knew, for instance, from the from like restaurant in Seoul, Korea or something, or that big church in Seoul, Korea, where that it was very clearly there. It couldn't have been droplets because people aren't spitting on each other.
That's right.
So it was aerosolized. As soon as we knew that, we knew a lot of things. We knew that masks were really not going to be very effective. We knew that telling people to stay in environments where there's low bad circulation would be a bad idea. In fact, we should have invested in better circulation in public environments.
Absolutely.
We knew a lot of things that can I just add one thing to this, which I like this analysis, but I just want to add one thing. Society is deeply unequal, right? Some people live in big houses with good air circulation, other people with lots of room, and other people live in crowded. Most people on Earth live in relatively crowded houses with poor circulation.
Yes.
Especially in poor countries, that's true.
Mm-hmm.
To ask people to lock down in those environments, it's not surprising there was so much in-home spread. Our homes are not designed to generally. Now, there was a certain class of people for whom the lockdowns were fine. Like if they have big homes, they don't lose their jobs. It really was this deeply unequal outcome. And it's therefore not surprising the lockdowns failed. For most of the human population, lockdowns are an impossible thing to truly comply with. You have to go to work if you're poor and feed your family. You have to live somewhere, and living in community with other people, your family, sometimes in crowded places in poor parts of the world, especially, but also poor parts of rich parts of the world. It's a policy that's conceived by people who are rich and can't conceive how other people live outside of their living circumstances. And so I think it was bound to fail. The physics of the virus spread, the living circumstances of most of the world's population, the deep inequality in the world was guaranteed the lockdowns. People couldn't comply most people in the world couldn't comply for very long periods of time without their family starving.
Yeah, we have a little bit of disagreement on this because I think if the people comply, they're worse off. And
that I agree with. By the way, that I agree with. Completely agree. Yeah, I don't think we disagree on that.
You see this thing where Cuomo was trying to explain the data. The data had come in where the people that did the worst were older, of course. We know that, but also predominantly at home. and predominantly non-essential. That means they were not out working, and they did worse than the people that were out working. So
Yeah.
going and
No,
locking down your house was a very bad idea.
I mean, in the United States, the work environments of many people have better air circulation than the home environments. So it's not surprising.
Sure,
And I
yeah.
agree with you. Like it's like if you live in a part of the US where you can make air circulation better by opening windows or whatever without freezing to death, it's great. In New
That's
York,
absolutely true. Yeah. If it's so cold outside that you can't open the windows, you're going to be much worse off, obviously.
yeah.
But
I mean, it's just,
so oh, go ahead. Sorry.
no, I was going to say, I think didn't Cuomo win an Emmy for this little performance that he gave you?
Yes, and I went into it in great detail in the book. If you saw that, I really was pretty hard on him because he did a lot of things that were terribly illogical and
Yeah.
very flippant. And I think the problem was, he started to think he understood this, and that's a very dangerous thing. And then he started making decisions as if he was a real expert in the medical part of it, and they were all wrong. And a lot of them
Yeah.
were caused death. Sending people back to nursing homes definitely caused a lot of deaths.
Yeah.
That's a big, big mistake. I mean, he had so many other places he could have sent people. He could have designated some nursing home facilities as for patients that have COVID already, so that there
Yeah,
weren't.
I mean, that was what Governor DeSantis did. I mean, I think part of the problem was, why do you have to empty out the hospital systems? I mean, the goal should have been focused protection of vulnerable people. That should have been the very first. If they had that goal first and foremost, instead they had first and foremost their goal of like emptying out hospital systems. Then you're going to make mistakes if you don't have the wrong goal. You're going to end up doing the wrong thing.
Yes. No question. I mean, he was trying to make room for people who didn't need the hospitals as much, if you will. It just made no sense. And that's when he got into trouble. And I have a theory about that, which we don't need to go into now, but I think he was a victim of it, thinking he understood this when he really did not understand it at all.
Yeah.
But you've got the National Health Service in England making the same mistake. See up here on the American one where Cuomo's explaining it, it says "Stay home, save lives." It's just the opposite.
Yeah.
And the NHS has the same catchphrase, and it's 100% wrong. You want to be out shooting baskets to save lives, really.
I mean, it's basically saying like, look, you should treat everyone as a biohazard in that bottom one, that NHS one. It's
right. Isn't that ridiculous? Message. Yeah, and it's so bad for sort of the social human interaction part of life,
Yeah.
Caused a lot of damage, I'll tell you. Anyway, the point I was trying to make about this is C is a house that is fully ventilated. They've got all the windows and doors open, and the particles just go right through the house. So it's not that difference between being in the house or outside if you're C. If you're E, no one in the house has COVID at the time, but it's going to have more COVID in it at a given time than the outside world will, because this is stagnant air. This is like the sand on the track when they're running a marathon. There's going to be more people plodding through the sand at any given time than on any other 100-yard segment of the track, if you will. And then down here, D, which is where you really don't want to be living, that's with someone inside the house that has it. So they're just pumping it out. They're pumping it out of their mouth the whole time, and it's not ventilated. That's trouble there.
Yeah. Well, everyone in that house is likely to get it unless they have some immunity.
That's right. And yes, exactly. Okay, so I just put a picture of my book in here because I'm going to refer to something I've already written in the book as we answer this. And this is asymptomatic transmission possible? And it turns out we were both right. I was saying it was impossible, and you were saying, well, maybe, but why are the data showing that it exists? And so here we go. Now, this is a page from the book, which I'm plugging the book here, but it is a good answer to it. And these are 31 physicians and scientists most brave and challenging the narrative. That's what this list was. And there you are, Jay, right there.
Nice.
And you've got Martin on one side of you and Sunetra on the other. And you can see your friends all through here. But under your title here, I almost want to read this. It's almost better. And then you can interject if you'd like to if you want to do it that way. I hate to read something, but it really explains it very well how we had this quandary there of having the data that showed that asymptomatic transmission was happening, and yet it did violate a fundamental principle. So here's the thing about this, though. This is incredibly important because asymptomatic transmission of one of these things is going to be the way that we wipe humanity off the face of the earth. Because if you have asymptomatic transmission for a disease that has a high fatality rate, a high IFR, infection fatality rate, you're going to wipe out humanity. Because if you have asymptomatic transmission of something like that, nobody's going to know who to avoid because no one will have any symptoms. And that
like
is
imagine airborne Ebola.
exactly with
Ebola.
no symptoms, symptoms, no cough, no fever, no nothing. Can you imagine what would happen to the humanity
like
if that were true? Half of us would die. You know,
yeah, pathogen like that would be absolutely devastating.
4 billion people would die from it.
Yeah, the only thing about that is, like, I mean, maybe you could make it in a lab, but evolutionarily, it would be unlikely that that you'd create a virus like that would propagate.
Okay, well, can I throw a crazy idea at you? You know, you can order these gene sequences now from a catalog.
Yeah.
Did you know that? There's 30,000 people in the world now that know how to put these things together like a puzzle by ordering the gene sequences from a catalog, and it's cheap. They only cost like $1,000 per sequence or something now. Used to cost 1,000 times more. Used to cost $1 million per sequence. They can order it now and put these things together, just like they put SARS-2 together. And is all it takes is one crazy person in a warehouse somewhere in 2 months of time and one assistant, and he could build it. And that's scary. And there are a lot of viruses out there that have a very, very high infection fatality rate. You know, Marburg and some of these real scary ones you hear about sometimes. And you know, this is something we have to. Oh my God! It says my meeting will end in 10 minutes. Oh, okay, how could that happen? I've already upgraded this and paid for it. Oh Jesus! It says upgrade. Should I hit upgrade and give him my? Let me do that and give him my credit card number. Maybe.
Sure.
Let me try it. I'm gonna hit upgrade. And if it pops on, I'll just type in the credit card. But anyway, it went off when I hit it. So look, do you think it's a mistake to read something like this in a video thing? It probably is.
Well, why don't you just explain it?
Okay, so we've talked about this, and what I was saying was that you and I had a disagreement because I kept saying you can't have asymptomatic transmission because it takes more viral load to transmit than it does to cause symptoms. You know, it put the fundamental principle of the order in which these things mature into spreading from person to person. It flipped the order of part of it. Okay, so that was a problem, and yet you did have solid data that showed there was asymptomatic transmission. So how did we resolve it? It turns out there's a thing in there that was put in called ORF8. Have you ever heard of that thing?
Yeah.
Okay, that little segment that they put in there, and I'll tell you some nefarious stuff that's going on. That little segment that they put in there made what we were both saying correct. And what it does is it's a protein that's produced, okay, from the genome that prevents interferon 1 from mediating symptoms. So you can have the virus that has enough viral load to transmit, but because ORF8 is in there, it's blocking symptom expression. So the people don't have any symptoms because ORF8 is in there. Now, you might recognize immediately, and I hope the audience picks up on this, that should be completely illegal to put these things in these gene sequences, because it's going to make something that normally would have a lot of symptoms, so it'd be easy to avoid them, symptomless. And so that will make it spread super fast, and it has a high mortality rate. Literally, people will just be keeling over in the streets from it. Imagine if smallpox didn't have pock marks all over the victim's face, and you didn't know who had it and who didn't. And that thing had a 40% fatality rate. So you knew who to avoid because it was real easy. They had pock marks all over them.
Yeah, the fact that people get symptoms, actually, it's not pleasant to get symptoms, but it in many ways protects society at large from being exposed. I mean, so it's a complicated thing, right? So, and also people, if they have symptoms, they obviously they feel sick, and so they don't go out as much. And so you'll get more exposure at home than you, for people that are symptomatic, than you would outside, because people aren't going to go out when they're symptomatic so much.
Right, but I mean, you don't want people with a disease, with a virus that can kill half the population. You need to know who to avoid and who not to avoid, or there's a real problem.
Yeah.
So that type of gain of function should be banned, not just frowned upon. And in China, Dr. Quay, who I interviewed and told me about this thing, because we were listing things, we were having a talk, and we were listing things that proved that it was man-made. And when I found out what this thing did, then I went, oh, that's the answer to when Jay and I disagreed on this, is that this ORF8 is in SARS-2, and that's what was keeping the symptoms from being expressed. And so it explains why it happened. These people that had huge viral loads that normally would have had symptoms didn't have them because ORF8 was blocking interferon from expressing the symptoms in the victim, in the patient. So Dr. Quay had found two master's theses that were never translated into English of people that were working at the Wuhan Institute of Virology on maximizing the efficiency of ORF8. In other words, they're trying to perfect this process where they can make asymptomatic transmission. That's scary, isn't it? You know, you can put a virus together that has a huge infection fatality rate, and then put this thing in there and it blocks symptoms. That could destroy humanity. This has got to be banned.
I mean, I do think that a lot of this gain of function work is quite dangerous, Reed. I agree with that. I think the argument, just to steelman it, the argument that people give on the other side is that that we need to be able to predict which viruses are likely to make the jump from animals to humans, and develop countermeasures like vaccines and other understanding of the virus before it happens, before the virus is most likely to do it. And the only way to do that is by collecting viruses in the wild, conducting experiments like these gain of function work to do that. The problem is that I think that it is we know for certain that keeping viruses in labs, especially active labs, even high security ones, without leak is not possible. Did you know that in late 2021, of a lab in Taiwan that was doing experiments on SARS-CoV-2, the virus that causes COVID, in 2021, it leaked out of that lab. We know that for a fact.
Wow.
I think it was a BSL-3 lab. I think the idea that we can keep these viruses in the lab and where we can do beneficial experiments without any risk to the population at large is a myth.
I agree.
And so I think the question is like, what are the potential benefits versus the risks? It seems to me like the risks vastly outweigh the benefits, the potential benefits. Okay, we know more about the SARS-CoV-2 spike protein because people were playing with it before. I mean, people knew about the spike protein because they were playing with coronavirus before. That's all fine. And we got a vaccine relatively quickly, a vaccine candidate relatively quickly. But that's not the same thing as an effective countermeasure. And if this was a leak, I don't know for certain it was, but if this was a leak, Reed, this is the worst scientific disaster of all time in peacetime.
Imagine if it hadn't had such a wimpy infection fatality rate, though. I mean, God, no, even if it could have been, if it was 2% or 1.5%, it would have been a disaster.
Well, I mean, like we were fortunate in many ways. The other issue is like this age stratification meant, in principle, we could have done focused protection as a strategy to protect people. Like, not every virus is going to have these features that make it more amenable to policy to mitigate the harm.
Right. I mean, I don't think the fact that we had the research being done on this thing beforehand helped us at all in this case. I really don't.
Well, I mean, we did get a vaccine candidate rapidly.
Yeah, but it was horrible. It didn't even block transmission. I mean, the thing didn't do jack. And it increased all-cause mortality more than it saved from people from COVID. Remember that graph I showed you that you said, boy, that's very disturbing. And we agreed that because the scale over there was way bigger than the one where it had helped like 5 people less get COVID and die. But the all-cause mortality was 50 more people. It was on a different scale altogether. It's much worse. Remember that? Remember that slide I showed you? Okay.
Yeah.
Let me just tell you the rest of this story here if I can, because I put in a physics thing in this section, which I won't read now, but I was talking about people who seem to be trial bound. What I meant by that was people who rely on trial results too much instead of just stopping and thinking about it a little bit. It sounds really bad for me to say something like that, because I do believe that whatever your idea is that you figured out by thinking, it has to conform with reality, or your idea is wrong, or your theory.
Yeah.
But I feel like in medicine, there's too much reliance on trials by some people, and not what would be ideal, which would be thinking it through really well and carefully, and then doing a trial to confirm your conclusions, if you know what I mean. In other words, use the data in a trial to confirm that what you theoretically figured out is correct or not. I think medicine would advance much faster if they did that. And let me just read this one example. And I ranked Dr. Prasad #1 on the people who were trial bound. He'd probably strangle me if he knew who I was, but
No, he agrees with that.
because he's a very fine doctor, clearly. But I just sort of tongue in cheek.
Well, I think, can I just say about this? I think the thing about there's an interplay between theory and empirics in all of science.
Yeah.
And theory has to be bound